Okay, so in this example, we are going to find the points of intersection between the curve y equals x cubed and the line y equals 9x, and we are later going to find the area bounded by the curve y equals x cubed and y equals 9x for x is greater than or equals to -3 and lesser than or equals to 3. So we are going to first start by sketching our graph. So our graph y equals x cubed will look like this. The line y equals 9x will look like this. So now, as you can see, that our curve y equals x cubed and the line y equals 9x intersects with each other. So to find the intersection points, we would need to equate equation 1 with equation 2. So we would need to equate y equals x cubed and y equals 9x. This is to find the two intersection points. So to find the intersection points, we would need to equate the first equation, y equals x cubed. The second equation, y equals 9x. We equate them together. So we now know that the points intersect at x equals 3 and x equals -3. So when x is equals to 3, y is equals to 3 to the power of 3, and this gives you 27. Well, when x is equals to -3, y will be -3 to the power of 3, and this gives you -27. So we know that the points of intersections are the points of intersection will be at 3, 27 and -3, -27. So we have already answered the first part of the question. So now we're going to find the area bounded by the curve y equals x cubed and y equals 9x. We knew already our intersection points, so we could label our intersection points. So this will be x is equals to 3, and this will be x is equals to -3. This will be 27, and this will be -27. This will be 27. The next step is for us to determine the area bounded by the curve and also y equals 9x. So the one I'm highlighting will be our y equals x cubed graph, and the one I'm highlighting in red will be our y equals 9x. Now, look carefully at our graph. We could see that there are two areas that are bounded by our boundaries, namely this area and also this. We have already identified the area bounded by the curve y equals x cubed and also y equals 9x. So now we need to find the area. Just like before, we could separate our areas into two parts. So this is A1 and this will be A2. And so if you were to focus on area number 1, and if you were to look at it closely, you could see we could actually obtain the area by using the formula to find the area of a region bounded by the curve and the x-axis. So it will be area 1 will be equals to interval AB upper function minus the lower function, integrate it with respect to x. Just like we have learned before, our interval will be from 0 to 3. Our upper function will be y equals minus x, and our lower function will be y equals x cubed. Remember, when you integrate with respect to x, the function has to be in terms of x. This then continues to be This gives you 81 over 4 units squared. And now if you were to focus in A2, the second area that we'll be computing, you should have seen that you could calculate area 2 by using the formula to find the area of the region bounded by the curve and the x-axis, just like what we have done in area 1. The integral of the interval from A to B. So now, our interval will be from -3 up till 0, and our upper function would be x cubed minus by the function 9x. And so you'll get this. And you'll integrate the whole thing with respect to x. Simplify further, you'll get so this gives you area 2 equals to 81 over 4 units squared. You would then need to add area 1 with area 2 to find the total area bounded by the curve and the function y equals 9x. Therefore, the total area bounded by the curve is equals to the area 1 plus area 2. So area 1 will be 81 over 4 units squared plus area 2 will be 81 over 4 units squared, and you'll get 81 over 2 units squared. So this will be your final answer. Now we're going to take a look at example 15. So the question asks us to find the area of the region bounded by the curves y equals e power x, the line y equals minus x plus 1, the line x equals minus 2, and x equals 1. So now the graph has already been given to us. So what we need to do first is we need to identify the region bounded by the curves. So I'm going to highlight the curves and also the lines. So we are going to see where exactly the region bounded by the curves and the lines are. Okay, so for the curve y equals e power x, this is the curve. Okay, and we have the line y equals minus x plus 1, so this is y equals minus x plus 1, and also the line x equals minus 2, and we have x equals 1. Okay, so now you can clearly see the region bounded by the curves and also the lines. So now let us look at the region which has its borders highlighted. So you can see that this region here, the borders are all highlighted, and this region here, the borders are all highlighted. It means that that is the region that we want to find the area. Those areas are the region bounded by the curves and also the lines. So now we're going to shade those regions. So because there are two regions, and I want to make it easier when calculating the areas, I'm going to label the first region A1 and the second region A2. To find A1, you could see that we could actually integrate from 0 to 1, and you take the upper function minus the lower function and integrate with respect to x. What we're going to do is we're going to take the interval from 0 to 1 and we take the upper function, so the one on top of the region, so y equals e power x. So e power x, so minus the lower function is y equals minus x plus 1. So minus x plus 1. So right now we are using the formula upper function minus the lower function. Upper function minus the lower function. Okay, so the whole thing will integrate with respect to x. So this is what we'll get. And then if you were to simplify this, you would get interval from 0 to 1 to find the area, you would need to start integrating. And then you substitute the two values, you'll get minus second bracket gives you 0. And if you were to calculate, you'll get 1.218 units squared. So this will be for your E1. So now we are going to find E2, and then after that we're going to add both areas to find the area, to find the total area of the region bounded by the curves. So now let us find E2. To find this area, you could actually see that we could use the same formula. We could take the upper function minus the lower function, and we integrate in the interval -2 up till 0. So for area 2, we could take from -2 to 0, and we take the upper function. So this is the shaded region, and the upper function would be minus x plus 1. So minus x plus 1, and then we minus the lower function. The lower function is this curve here. So this curve belongs to the curve y equals e power x. So minus e power x. And you'll integrate the whole thing with respect to x. Simplify it further, and we'll get from -2 to 0, minus x plus 1 minus e power x. So we're going to integrate this with respect to x. And remember that whenever we want to integrate with respect to x, our function has to be in terms of x. So now we'll start integrate. And you integrate e power x, you'll get e power x. So this will be from -2 up till 0. And this gives you 3.135 unit squared. Okay, so right now we're going to find the total area. We knew already our E1 and E2. Now we're going to add both areas. So to find the area of the region bounded by the curves. So the area of the region bounded by the curves will be A equals E1 plus E2, because we've separated into two parts. So 1.218 unit squared plus 3.135. So this gives you 4.353 unit squared. Okay, so this will be your final answer. So to test your mathematics skills on this subtopic, please try these questions.